Good morning, everyone. Am I audible? Am I audible to everyone? Okay. So, in the last class, we were discussing about transition table as well as transition graph or transition diagram. Basically, these two are the notations for representing DFS. Any query in these two in the notation part? Any query? Anyone? Or we can just move to the next topic. Anyone? Any query? Okay. Okay, let's start the next topic, which is called the language of a DFA. Let me share my screen. The language of a DFA. In the very first class, I have mentioned that while we are discussing about DFA, some aspects we need to remember. This is called the grammar, the strings, and some kind of languages. That means we are defining some DFAs based on some languages or using some languages. Suppose we are writing an essay using a language, either English, Hindi, or Assamese. Similarly, when we are defining some DFAs, we are basically using some language, and in this process, we are generating some strings or we are validating some strings, and the strings are comprises of some input symbols. Okay, what is a language? Okay, the language we can there are several definitions or several points through which we can highlight the definition of language. So basically, when we are start the study of a machine, okay, when we start the study of a machine, we start the study of the machine by using the automata, because automata means this is a process of study of machines. Okay, so basically automata of all kinds define language. And if we can say that if A is an automaton and L of A is its language, that means without a language we cannot study or we cannot start the study of a machine, because without a language we cannot start the writing of an essay. For example, suppose you are writing an essay on suppose flood. While you are writing the essay, you are describing about flood, its impact, its reasons, its preventive measures, everything. It means you in this particular essay you are describing about a particular concept, suppose flood, science and technology, or anything. Okay, you are writing a blog on traveling. While you are writing some blog, you are writing about a particular place within a blog. Okay, so that means when you are writing. Okay, okay, let me unlock. Okay, so, so while we are writing something, writing about a particular place or particular movie, we are describing about a movie or particular place, but for that we need some kind of language, either English, Hindi, or Assamese. Here also, when we carry out our study about a machine, we need to explore the machine. We need to highlight its characteristics, its uh, way of doing things, way of doing executions, etc., etc. Okay, but to do to all kind of things, we need a language. Similarly, we need a language to express about something, about a place, about a particular element. Similarly, here also we need some language to represent the study of the machine. That's why if A is denoted by the study of the machine, then L of A is its language. Next point, for a deterministic finite automata, L of A is a set of strings labeling paths from the start state to final state. That means using a language we can define the starting comma, the intermediate steps, as well as the final step. Okay. Formally, L of A equal to the set of strings W such that transition function I have I have already unlocked Nilton. Ask him to join. Okay. Yeah. L of A, the set of strings W such that delta Q not starting state the string W is in a final state. That means this string means the input symbols, the set of input symbols. Okay, the set of input symbols we have to go through one by one and we have to reach the final state. This is language. That means suppose in language, using the language we can get the string, and using this string we can validate whether the string is accepted by the deterministic finite automata or not. For example, suppose String in a language. Example, string in a language. Okay. Suppose there is a string called 101 is in language of a DFA below, because in a language we can define a string 101. Hello, am I audible? Am I audible now? Hello. Okay. Nilnoton, please check your audio. Okay. That means it is a string, and this string is in a language. Okay. Okay. The string is 101. So we have to define whether this string, which is defined by using a particular language, okay, is acceptable by the DFA or not. Okay. Suppose we start from a 101. Okay. Yes. From A to B, we use the input symbol 1. We reach B. Then next input symbol 0. From B, we reach A, and again this one, and from A again we reach B. 101. And finally at level 1 from current state A, result is in accepting state. So 101 is in the language. That means the language which is defined and the string is generated from this language is acceptable by the DFA. Or in other way we can say that if the string is accepted by the DFA, the string is within the language. In both way, suppose, for example, suppose if we get this type of marks, or this kind of marks, actually, suppose minimum requirement this one, if we get this kind of marks, you will get the admission in the particular college. Or in other way, if you get the admission in that particular, that means your minimum percentage is this one. Okay. So that means a language is defined. We are given a language, we are given a string, and we are given a DFA. Now you have to find out whether the string is in the language or not. And to identify these things, whether the language is within the whether the string is within the language or not, you have to, what you have to do, you have to verify whether the string is accepted by the DFA or not. Once the string is accepted by the DFA, that means the string is within the language. Because always remember, when we are defining a DFA, we use some language. For a particular language, there is a particular DFA. That means DFA can be derived from a language, and the DFA accepted many kind of strings. Okay, we have a string and we have a DFA which is derived from a particular language. Now we have to define whether the string is within the language or not. We cannot directly define it. What we have to do, we have to verify whether the given string is accepted by the DFA or not. If yes, that means the string is within the DFA, and if not, the string is not in the DFA. So similarly, suppose if we consider a string called 1011, 1 1 0 1, then 1, we traverse all the states, but all the states as well as all the input symbols, but we are not reaching the final state. That means this string is not accepted by the DFA. That's why the particular string is not in the language. Is it clear to everyone? Okay, but please don't get confused. We have to uh, classify these things. That means first of all we have a language. Using this language we are defining some DFS, and using this DFA we are verifying whether a particular string is within the language or not. And for this we have to find out whether the given string is accepted by the DFA or not. If accepted by the DFA, which is defined by using some specific language, then the string is within the language. Okay. And it is not like that every time we have a language, using this language we have to define a DFA. Okay, in sometimes you will get that you got the DFA, now find the language. That means both way we can do our experiments or execution in both way. Either we have a language, we can derive the DFA, or we have the DFA, from this DFA we can define the language. And L of A, if A is the automation or A is the DFA, okay, then L of A is the language. Now write a question. Right, the design a finite automata. Wait for a minute. Okay, write the question. Define a FA. FA means finite automata that accepts set of string that accept set of string such that every string ends in double zero. Such that every string ends in double zero over alphabet or input symbol over alphabet or input symbol like suppose this one, this to the input symbol 0 and 1. Okay, that means what you have to do in this particular, okay, this is it is a one kind of language. That means the language is like you have to derive the string using a particular language. Okay, and in this language the condition is that the string you are going to derive, it's end with two consecutive zeros. Okay, two consecutive zeros means suppose in at the end of the string there may be two zeros. After before that we can use a combination of zeros and ones, but the last two digits should be zero. Can anyone define a string by satisfying this condition? Yes, 100. Anyone else? Anyone else? 1000. Anyone try some other type of strings? Those 11001010. Okay. Now, can anyone tell me how many states are required to draw the DFA for the above mentioned language? We have two input symbols. We can make combination of strings by using two input symbols, but the string should be ended with two consecutive zeros. So my question is how many states? Sir, C do not have double circle. I did not get Onkomani.
Sir,
কি কৈছা মই বুজা নাই কি C do not have
sir, C state or double circle নাই.
ক'ত ক'ত ৰিপিট কৰাচোন কি কৈছা বুজা নাই
State ডাবল সার্কেল নাই যেনেকে এ আৰু বি ডাবল সাৰ্কেল আছে মানে
No, no, no,
ফাইনেল
don't confuse over this DFA. This is not DFA. What we are talking about is something different. It is not related to the DFA which is available in the screen. Forget about it. Just just concentrate on the questions we have discussed, because the design a FA that accept a set of strings such that every string ends in double two consecutive zero. It is something different. It is not related to the uh, DFA which is highlighting in your screen. We have to define a new DFA. That means we have a language, that there is a language in which we have to define a DFA, and for this DFA, what are the strings we are using? The strings end with two consecutive zeros. So final state will have a self loop. Now question is, for this particular question, how many states we needed? Zitul, three states. Anyone else? Three states. Anyone else? Anyone else? Yes, we need three states. Can anyone draw this DFA? Okay, let me share the screen. Is my screen is visible? Suppose using this language, we are defining a string called 100. Okay. Now we have to validate whether this string is satisfy the condition or the language or not. And for this, we have to verify whether this string is accepted by the DFA, which is defined by using the particular language or not. Suppose we consider 100. This is the starting state, this is the final state. Okay, that means from starting state we have the first input symbol 1, then using 1 we are reaching the same state. This is circular loop. Okay, then we have 0, using 0 from q0 to q1, then again using 0 from q1 to q2, and we completed the traversal of the string, and as well as we reach the final state. That means this particular string is accepted by the language or accepted by the DFA. That means this string is within the language. Okay, is it clear now? How that means how you have to define whether a string is accepted by the DFA, as well as how you have to define whether a string is within the language or not. For both way the process will be same. You have to verify whether the string is accepted by the DFA or not. Is it clear to everyone? Is it clear to everyone? Okay, the my suggestion is to all of you, go through the topic again. Okay, try to derive some DFAs by using some language. There are so many examples in the internet. Okay, so my this meeting will end in 5 minutes, so I will continue in the next class. So before going to end up this session, I just want to tell you that you have to go through this. Okay, pick up one or two questions and try to solve it. Try to define some DFAs, try to define some string, and try to find out whether the string is acceptable by the DFA or not. Okay. Okay.